Okay, we're going to go ahead and get started. I'm Reese. I'm filling in for John today, who is in Detroit, and so I'll be filling in for him today. So, we're kind of coming pretty close here to the end of the semester, and today we're going to be starting on kind of the second kind of data science module that you guys will be learning about, and then at the end of next week you guys will start learning about the last module, and then after this pandas module you guys are pretty much done, and then it comes the final exam. So we're getting really close here to the end of the class. So today's game plan is I'm going to finish up where John left off on Wednesday with some last second NumPy stuff, and then I'm going to quickly go over a solution for Lab 11, because I know you guys want to see some more like solutions or answers to some codes, and so I'm going to quickly kind of go over just like a solution for Lab 11, and then we will get into the matplotlib. Does that sound good? Thank you. Okay. So where we left off on Wednesday, we were working with this NumPy example here, right, where we had this array of person objects, and what John said on Wednesday was try to get it so that when it prints out, that these names will be sorted in order, right? So like if I run this, it should be sorted by last name, and so it should be Brown, Cassilis, and then Wessel. And what he said is to look at this built-in NumPy method, numpy.sort, to try to get this sorted in alphabetical order. Did anybody actually figure this out? Okay, good. Because it turns out you might have gotten bamboozled a little bit. It turns out John Paxton himself couldn't figure out how to do it with the built-in NumPy sorted method, and I couldn't figure it out either. So I think it's possible somehow using the NumPy library, but we couldn't figure it out. But we did figure it out. But what we're going to do instead is we're going to use the built-in Python method for sorting stuff. And so, so this is going to be sorted. That's the built-in Python sorting method. And so what I'm going to do now is I'm just going to look at the documentation for the Python sorted function. Let's just search for that, see what we get. Good old Geeks for Geeks. This is an actual Python documentation, but this is kind of helpful for what we want. Okay, so the sorted kind of function here, it's built in, right? It sorts any sequence and will always return the list of elements in a sorted manner. So if we look at the syntax here, we call this sorted method, and we pass in an iterable, which is like the data structure that we want to sort through, and then we give it a key, and then something called reverse. Okay? So iterable, right, is the sequence, it's the list, the tuple, the string, the array, or collection that needs to be sorted. The key is a function that would serve as a key or basis of sort comparison. So what this means is the key is pretty much like what we want to sort by, and then reverse here is just if we set reverse to true, then the iteration would be in like backwards order. It'll sort in descending order, which we don't really want here, right? We want to sort in alphabetical order. We don't want to sort it reverse alphabetically, but we will we'll be working with that sorted method here. Okay? So we want to sort, so this function right here, that will return an array in this case, because we're going to be sorting an array. It's going to return that array to us sorted, and so we actually have to like update the value of our array. So I'm going to say people is equal to whatever this function returns. Okay? And so you can even see that when I start this open parenthesis for the sorted method, it tells, hey, we're giving it an iterable, a key, and a reverse. Okay? So what we're sorting is that's just going to be people, right? And then we need to give it a key, which is pretty much what we are sorting by. and we want to sort it by last name, but if two persons, have the same last name, then it should go to the first name and sort by the first name. Okay? So, it turns out that this is going to involve some little bit of advanced Python kind of structures. So, here's the actual answer. I'm going to say key is equal to this thing called lambda. I'm going to say x, and then I'm going to say x dot last, comma, x dot first. Okay? Let's see if I can maybe make this a little wider. Okay? So, I'm going to explain to this what this does. So, we want to sort by the last name, right? And so what this lambda is doing is lambda is what we call an anonymous function. So what we've done so far with functions, right, is that all functions have a name, right? They have an identifier. We have a function called main. That's the identifier for main. We have a method called isIt, low roll, isIt, high roll. Those are all functions with names. An anonymous function is a function that does not have a name. Okay? So this lambda means that everything that comes after lambda is going to be an anonymous function. All right? So the syntax of this is that this function, this lambda, the input is going to be this variable called x. Okay? And in this case, it's just going to be a person object, and it's going to return to us a list of each person's last name and then each person's first name. All right? And so like this is pretty much like a function on a single line, which is really, really cool. It's really confusing, but hopefully this will make sense in a second. And so I guess for now, let's just say x.last. And if we run it, we're getting invalid syntax because I forgot end parenthesis. We noticed that what we're sorting by, right, we told the key that we're going to be sorting by the last name because that's what our function returned, okay? And we see that we get everything sorted by the last name. But now we need to handle the case where, right, so we have like Ali and then we have Max. Ali should come before Jacob, so it should be Ali, Jacob, Max. They all have the same last name, but we should sort by the first name. So that's why here we're going to do a list. I'm going to say comma first, because remember that when we're sorting with if we're sorting lists of lists, it will sort based on the first entity in the list first, and if for whatever reason two last names are the same, it's going to go to the first name and it's going to say, okay, if these two persons have the same last name, we'll check the first name and sort it by the first name. And if we do this, we see that we get it sorted in the manner that we want, sorted by last name, but if they have the same last name, we sort by the first name. Okay? So the lambdas, this is pretty much just a one-line function. It's gathering all of our person's first names and last names, and that's going to be like what we're sorting by. So it wasn't expected for you to know lambda, but if you were to Google this, you probably would come across some code like this. You won't be tested over lambdas, so it's not important to really remember them, but this is like a really cool structure, because what ends up what you could do with this is you could have a function that returns a lambda expression. So you'd have a function that returns a function, which is really cool to think about. Okay, any questions on this?
What if you had a third, a middle name? Would you just do x dot middle, or how would it know to determine first and last and middle?
Yeah, so this is kind of like an order of presidents, right? So it will first sort by the last name, then it will sort by the first name. We could say x dot middle here, and it'll sort by the middle name last. So it's pretty much just whatever this lambda function will return. We would have to define a middle name, right, and put a middle name for all these guys. But we could totally implement a middle name and just put it in our list wherever we want to put it. Yeah?
Does x dot last reference self dot last?
It does. Yep. X dot last represents each individual object's last name. So yeah, it does kind of reference self, I believe. Cool. All right. So that's it for NumPy. We're done with NumPy. Well, I guess you're not done with it because you have to do it on the program. But we're done talking about it in lecture. And so now what I'm going to do is I'm going to quickly go over a Lab 11 solution. But I'm going to fly through it pretty quick because I like to get to the matplotlib stuff. So I have Lab 11 right here. I have it downloaded beforehand. And so I defined all these three functions already, but I just said return false for all of them, just so that it will run. Okay? So most people in what I saw, most people seem to they did pretty well on this. I don't think this lab was too bad. It was really similar to program 2 where we were evaluating poker hands. Kind of some very similar logic here. So, okay. So let's start off with doing a low roll. And like the key that not many people realized first was we had a method here called count outcomes, which created an array for us called counts. And it was pretty much like an array that like stored the frequency of how many times each number was rolled. So it had how many 1s were rolled, how many 2s were rolled, how many 3s were rolled, how many 4s were rolled, up until how many 8s were rolled or 9s were rolled. I don't remember what it was. Okay, so like what ended up happening is we're going to be using that count array for us, and we actually have to get it from this method because that counts array it only exists in this method. So if we want that array, we actually have to call the function that will give it to us. So I'm going to say counts is equal to count outcomes, and I'm going to say I'm not going to say self. I'm just going to do that. That's going to call the method. It's going to return to us the counts array. And if we run it, we say that name count outcomes is not defined. Does anybody remember why this is? Yeah. Exactly. Count outcomes is in a class, right? So in order to call this method, it's expecting an instance of an object, self. So we have to call this method on like an actual object. And now we see that it compiles, but still nothing is happening. So I'll say this right away. There are so many different ways that you could do this. Like I saw so many different solutions, and like even last night, preparing for this lecture, I was kind of checking various solutions to this, and people were kind of all over the place, but people were getting the same answers, which is really cool. So I'm going to go over just kind of what I was thinking. So when I'm kind of thinking of starting this lab, I usually try to like visualize kind of like what a low roll would look like, or what a three of a kind would look like, or a large straight would look like. And so I'm going to boot up DocCam, and let's see what I can do. So what I have here, I don't actually know if this is going to show up on the lecture recording, but so here we're working with the low rolls, and here's one example of the counts array, okay, right? Because our counts array has 9 spots. So this 2 right here, this represents like how many 1s were rolled. This 3 represents how many 2s are rolled, how many 3s are rolled, how many 4s are rolled, and so on and so forth, right? And this would be a low roll, right? Because we have 2 1s were rolled, and then 3 2s are rolled. So all of our rolls were either a 1 or 2. Here is another example of a low roll. You just flip those numbers around. Here's another example of a low roll. We could have 1 1 and 4 2s, right? Or we could have it the other way around. Here's 2 more ways. We could have 5 1s and 0 2s, right? These are all examples of low rolls, and in fact, those are the only possible ways that we could have Those are the only possible combinations we could have for a low roll if we're rolling 5 dice, right? I'm not missing out on anything, right? So what I'm kind of do now is I'm going to look for patterns in here and see like what is like a shared trait among all of these combinations, because we want to come up with a general solution that will work for any case. And so I'm looking at this, and I would notice that like, hey, the number of 1s rolled and the number of 2s rolled, those two numbers will always add up to be 5 in this case, right? Or more generally speaking, both these numbers will add up to however many dice we rolled, right? If you rolled 10 dice, those two numbers would add up to be 10. If you rolled 5, those two numbers will add up to be 5. And so, let's see. I'm going to hop back over to the PC and make sure I'm still recording. Cool. My mic still? Okay, yes. So kind of putting that into words, I could say if counts index 1, so however many 1s are rolled, plus counts index 2, if those two numbers equal 5, then we can return true, and we can get rid of this down here. And so if we run this, we see that we get around 0.1%, which is what you should have been getting on yours. That's kind of the right percentage we should be getting. And if we run it again, we should get something a little different, but very close to what we had before. And so, like, more generally speaking, that if statement will only work if you roll 5 dice. Like, what if we roll 10 dice, or 20 dice, or 1,000,000 dice? So a more general way of saying this, we would say, I need to remember how this is. It's going to be self.rolls.size, okay? So the size will pretty much get, right, how many spots are in that array, right, because this represents how many dice we rolled. So this is pretty much going to evaluate to be 5 or 10 or however many dice we rolled. Does that make sense, how I did that? And like I said, that's just one general solution for that. Cool. All right, so now for 3 of a kind. So for 3 of a kind, there's kind of 2 things we needed to check for. When we're working with 3 of a kind, we're still going to be working in the counts array. Here's one example of the counts array. We have a 3 of a kind, right? So that represents how many 1, 2, 3s. We rolled 3 4s, and then we rolled 2 6s, right? And it turns out like this is not 3 of a kind because the 2 other numbers are the same, and so like that would be like a full house, I guess, if that's a thing in Yahtzee. So that is not 3 of a kind, right? Instead, an array like that is what a 3 of a kind should be, where the 2 other numbers, we had 2 1s, that means the 2 other numbers were different than what was the 3 of a kind, okay? So what I'm thinking is there's like 2 things we need to check for. We need to check that there is a 3 somewhere in our counts, and there is not a 2 in there, right? All right, so if I come back to 3 of a kind, we're going to start off the exact same way. We got to get our counts array, and so putting that into Python language now, I'm going to say if 3 in counts, okay, that's going to check to see if a 3 is in the array, and 2 is not in counts, then we can return true. Okay? So it's going to check. We have like 2 different conditions here, right? We have 3 in counts. It's going to check that, and it's also going to check that. And since we're combining them with an AND statement, both of those expressions have to be true in order for this return true to get hit, right? It's only going to return true if both these conditions are true and only if both those conditions are true. Okay? And if we run this, we see I have a typo in my method call. Okay, and if we run this, we get around 10%, which I believe is what you should have been getting in the lab. I think it was around 10%. Okay? Right, so that's the solution I came up with that. Does that make sense? Is there a case where this doesn't work? Because I'm convinced that my solution isn't the best, because like this will only work if we have 5 dice, I believe. So there might be a more general way of coming up with this second number for checking to see the rest of the dice, but this is the solution I came up with, and I think it's pretty straightforward. Any questions on that? I'm convinced there's some problem with that, but I haven't ran into it yet. Okay, so now for for large straight, and you know, if you looked at this and you might have had some like deja vu or something, that you've seen something like this before. It turns out you did something like extremely similar, or you did exactly the same thing in program 2. We were working with poker hands. You found a large straight with poker hands, and it turns out the exact same logic, the exact same code can be used here. And so going back over to the doc cam. So if we have a large straight, I'm going to say we're going to be working with the rolls array now. We're not going to be working with the counts array. And so here's an example of a straight, right? We have 3, 4, 5, 6, 7. Here's 2 more, right? Those are all straights. Now, one of these arrays is a lot easier to evaluate than the other 2. It turns out, and you might remember this in program 2, but that third array is much easier to evaluate for large straight because it's an order. We know that if it's an order, the lowest number will always be at the beginning, and then we keep working our way up, and we know that the last number will be the largest number. And before, when we're working, if we just have like a scrambled kind of array, we're going to have to search the entire array each time to find the next number. So it's a lot more efficient if we sort it from the start, okay? And so, my general kind of solution I'm thinking for finding a large straight is if we have this array right here, 1, 2, 3, 4, 5. The idea here is that we're going to start off right here, and we're going to check to see if that guy plus 1 is equal to that guy. And then we're going to check to see if 2 plus 1 is equal to 3, and we're going to do the same thing for all of the numbers in our array. Does that make sense? Okay. So I'm going to pretty much do that now in Python. Okay, so if we want to sort that array, that's the first thing we need to do. We're going to say self.roles is equal to np.sort self.roles. That's going to sort it from least to greatest. And so we're going to iterate through all of the spots in our array. So I'm going to say for I in range self.roles.size. I think before you might have done the len command with list, but here we're going to be doing the dot size, which is going to be the exact same thing. Okay, so I'm going to see if the current number we're looking at, so if self.roles index I, if that spot plus 1 is equal to the spot ahead of it, so self.roles I plus 1, if that is true, then do we want to return true right here? Did I hear a no? No. No is the correct answer. and I should probably scroll that down, because like we're going to check like the first like pair, right? So I'm just gonna say something like this. Like, what if we had the array 1, comma 2, comma 5, 6, 8. Okay? Our algorithm here is going to check this first pair, and it's going to check to see if that guy plus 1 is equal to 2, which it is, right? We have like the start of a sequence here. And so, based on our code so far, it's going to return true right away. But we haven't checked the rest of the array yet. So we're returning a little bit too early. Okay? So what I'm going to propose instead is, instead of checking to see if they're equal, I'm going to check to see if they're not equal. And if they're not equal, I'm going to return false. Okay? But the idea here is that after I've gone through my entire array, if I never return false, right, then that means I have a string. So I will return true. Does this kind of make sense? I think we've kind of structured something like this before, where we check to see if our condition is not true, we return false. But after we've gone through all of our spots and we check all of the kind of different pairs, if those pairs never flagged as false, then we're going to return true at the very end. If you run this, we're going to get an error here. It's saying we're getting an error on that if statement line, and it's saying index 5 is out of bounds for our array. Does anybody know why this might be happening? Yeah.
Because the size of the array is 5, so it goes 0 to 5. So if we subtract 1 from the self.roll.size.
Right. So our array is self.rolls.size. That's going to be 5, right? Because we start off at 0, 1, 2, 3, 4. That's 5 spots. So this range here is just going to generate the range of 0, 1, 2, 3, 4. Because remember, that 5 does not get included in the range. And if let me jump over to the doc cam here. So if we have index 0, 1, 2, 3, 4, remember that 4 was included in our range here. So it's going to check to see if self.rolls index 4 plus 1 is equal to, I don't know, I plus 1, right? We did I plus 1 for the index, but 5 does not exist in our bounds, right? We're checking a little bit too far in our array, because when we reach the end, we don't need to check, the next spot. Right, so we're checking outside of our array. Hopefully that makes sense. So the fix for that is we just say self.rolls.size -1. That way, the 4 and the 5 will be the last pair we're checking. And if you run this, we will see that we get our 1%, which is the right answer. Okay? Does that make sense? Any questions before I get into matplotlib? Good deal. Okay, so matplotlib, right? So the next 3 weeks, matplotlib and pandas. This module is all it's going to explore the different ways of how we can visualize data. So we're going to be making graphs, pretty much. We're going to be making graphs, and I like to think that this stuff really isn't too bad. Most of it just requires looking up documentation, which can kind of be a pain sometimes, but we're going to be practicing looking up documentation to figure out stuff. So if we kind of look at today, we see that just like NumPy, we're going to need to install matplotlib, and it's going to be installed the exact same way as NumPy, except you're going to say pip install matplotlib. So if you know how to install, if you got NumPy installed, you should be able to install matplotlib. Cool. Okay, so what I'm going to do is we're going to download this code right here, and we're pretty much going to be experimenting with this code for the rest of the class. So if we just jump over to that, I have it right here, and I'm going to bring up the shell on the other side. And we see that we're importing the matplotlib library as well as numpy and the math library. And if you notice that we're importing matplotlib.pyplot, which is how we get the plots, we're importing that as the phrase PLT. So whenever you see the PLT down here, you're referencing the matplotlib library, okay? So if we just run this and we see what happens, this is what we get. We get a figure, which is like a graph, and we get like 3 lines right there, right? We get, you know, those 2 diagonal lines, and in the center we get that squiggly line. And if you take a look at our axes, we're going from -100 to 100 on both sides. So let's take a look at what's going on here. I'm going to scoot that over a little bit. So if we go to our main function, we notice that when we call our main function, we pass in -100 and 100, okay? And what that is, that's like the graph min and graph max, right? Remember that we saw -100 to 100 on the axes? So that's what those numbers represent, okay? And so like the idea here is that we're going to be plotting some data on the x-axis and then some data on the y-axis, right? But there's a lot of things we can do with the matplotlib library that will allow us to like customize our graph and to change a lot of like the visual stuff. So if we take a look at how we start off, we say plt.xlim and plt.ylim, and we pass in the graph min, -100, and graph max, 100 for both of those. So what this is this is like the x limit and the y limit of our axes. And just to show you, if I multiplied the graph min and the graph max by 2 on the x limit, right? So that's going to be -200 and 200. If you run this, we should expect that, you know, now we see we get -200 to 200. And right, our graph kind of got smushed together because we have a longer x-axis. So that's what the x limit and y limits are doing. It's how you can kind of set like the range of your axes. And then we have a function here called plot line, okay? And we pass in 4 things. We pass in -100, -100, 100, and 100, okay? So if we take a look at our function here, we kind of pass in an x1, a y1, an x2, and a y2. And so, right, so just to kind of show, so x1 was -100, y1 was also -100, x2 was 100, and y2 was also 100, okay? And we see that we create some list, yeah, because we have brackets, a list called x and y, and we pretty much put all the x points in our x list and all the y points on the y list. And then we call plt.plot, and as you can imagine, this is what actually plots the data. So we're plotting our stuff on all of our x data for versus like all of our y data. So it's pretty much what's going to do is it's going to pair up x1 and y1, and it's going to interpret that as like a single point, and then it's going to like tie together x2 and y2, and it's going to interpret that as like another point, and then the plot will pretty much connect all the points that we're plotting. And we also say gold, and if we take a look at the graph here, this is the gold line right here, right? And if you kind of notice that, right, we had our x1 and y1 down here, -100. That was a point down here. And the other point was 100, 100. And it connected those lines. That's kind of what that's doing. And when we're doing the dot plot, we can actually give it like the color that we want the line to be. So I could change this to green, the string green, and we would see that it changes like the color of the line. Okay? Any questions so far? Okay. Then we have some more numpy stuff, so we're actually not done with numpy. We create an x array and a y array, and it's going to be the exact same thing, but here the point now is negative 100, 100, and then 100, negative 100. And so we just saw an example where we plotted two lists. More frequently, you'll be plotting two arrays. That's kind of what we're doing here, right? We have two numpy arrays that we're graphing, and it's going to work the exact same way. We do the dot plot, and we give it the x array, and then we give it the y array, and then we don't need to give it a color, but we say we'll do blue right there. And so if we take a look at our blue line, we see that we have a point right here, negative 100, 100, right? Negative 100, 100. And then down here we have 100, negative 100. So there's the 2 points, and it connected those 2 points together with a line. Okay? Cool. And lastly, we have a plot sine wave function, okay, which just by process of elimination, this is a function that's going to plot that squiggly line, which is going to be a sine wave. And so we pass in the graph minimum divided by 2, the graph maximum by 2, and the graph max divided by 4, right? And so this double division sign, that's how you floor something. So if you get a decimal, we'll always round it down to the next, or round it down to the nearest integer. Okay, so if we take a look here, the plot sine wave, it takes in a starting x and a stopping x, and it takes in an amplitude, right? So we passed in graph min divided by 2 for the start x, graph max divided by 2 for the stop x, and graph max divided by 4 for the amplitude, okay? So if we take a look at what's going on here, we create two arrays here. We have an mp.linspace, which is a linear space, which is like a fancy word for saying like an xy coordinate system. And we give it, it's going to go from the starting x and the stopping x. And what this number means, I believe, I'm not an expert on matplotlib, and so I think I have the right answer here. This 1,000 represents like how many points this array is going to have. Okay? So like what that 1,000 would mean is like we're going to have 1,000 points that we're going to like plot pretty much. And then we say the y array is equal to the amplitude times mp.sine. Okay? So here we're making another numpy array, but we're working with the sine kind of trigonometry function here. And what I believe this does is it takes in the x array, and it's going to run the sine function on all of those, x values, and all the y values, or the output of the sine functions, are going to get put in the y array. And so, and then we do the plot array, we plot the x array and then the y array, and we see we don't pass into color because it's not required. And so if we look closely here, and if you really want to zoom in, you can click this magnifying glass down here, and you can drag this, and you can see that we started on negative 50 and 50. And if you look at like how tall this graph goes, it goes to negative 25 to 25, right? And so I'm going to change this to 10. I'm going to run it. And what we see is we get something, but it's not really like a sine wave now, right? Because remember that it's going to draw a straight line between the individual points. So, like, before we had that more circular curve, it looked really round, right? But it turned out that we were just connecting a lot of different points together. Right here, we're only connecting 10 points together. And so, if we change that back to 1,000, and we get what we went before, and remember that like the amplitude, that's why we had to multiply the y values by the amplitude, because remember the sine function, if you remember back to math class, sine goes from negative 1 to 1, negative 1 to 1, negative 1 to 1, back and forth for forever. If we multiply it by an amplitude, if we multiply it by 25, it'll go from negative 25 to 25. Okay? Any questions on this code? The last thing I'll mention is that there's this plt.show, and this is really important because this is what actually will open up that window with our graph. So if I actually like deleted that, we would see that a plot would not appear because we didn't actually tell Python to show us our plots. And this should always come last, because if we do this at the, if we did it like right here, right? We get a window, but nothing is plotted yet because we haven't plotted anything. We have to plot it first before we show it. And like if we pasted it right here, so before we plotted the sine wave, if we run it, we see we don't get the sine wave because we plotted the sine wave after we've showed it. Okay. So I mentioned that because that's a problem I see a lot of time with matplotlib, is students will come to me and ask, why is my plot not showing, or it's not actually showing the graph, or nothing's happening. It's because you actually have to show the actual plot itself. Okay. So now what we're going to do, we have 9 minutes left. Wow, okay. We're going to do some of this in-class activity that's going to require us to look up some documentation. So we're going to modify our graphs so that our x-axis gets a label called x, and our y-axis gets a label called y. And then we're going to modify it so that it plots the straight lines with magenta dashed lines. So there'll be a dashed line instead of a solid line, and they'll be colored magenta. And then we're going to modify that so it draws a sine wave with our points of size 5. So we'll be able to actually see our points that we're plotting, like because it'll be a much bigger size. And then we're going to replace this the x-lim and y-lim with a single statement called plt.axis. Okay, I would say we're going to do this as a class. We're going to do this this labeling first. So what this is going to end up happening is we'll have an x label down here called x, and a y label here called y. And so it turns out, let me just Google x label matplotlib. If you take a look at documentation, we see that there is an x label function that takes in the text of what you want to name it. And so I'm moving a little bit fast here, but if I just said plt.xlabel, and I said x, oops, and if I run it, we see that we get an x down here. Sorry if you can't see that, but we get an actual label now. And I could change that to whatever I want, any string that I want, it would work. Turns out it's the exact same way with the y label. So we'll change that to y. And if we run it, we get our y now on our y-axis. Okay? First part done. All it took was a Google search and looking at documentation. And even if documentation isn't clear, sometimes you'll find like examples of like how it works. Okay? Next thing is we're going to do this where we're plotting straight lines with magenta lines. If we take a look, we see that he gives us a hint here, and it takes us to the dot plot here. And if we take a look here at like some of the examples, we have this plot. We give it an x and a y, and then we could give it an x, a y, and this string bo. And if we take a look, this plots x and y using blue circle markers. So what this is actually this string here. This first b stands for blue. So it's going to turn our line to, it's going to make the markers blue, and then it's going to change the markers to like actual like visible circles, because like what we have right now, the points are there, but they're not actually marked as anything, and so we'll actually make those with dots here. And right here we're doing red, but with like our points will be a plus sign instead. And if we take a look at like all the different combinations here, we have like a solid line style. We can give it a dashed line style. We can give it a dash dot line style, and then we can also make our markers the shape of pentagons, stars, plus markers, diamonds. And so, okay, so if I come back to the code, maybe I can implement this with using this dot plot. And so so maybe we'll turn this blue line into our dashed magenta line. So just to start off, if we want to change the magenta, we could do just an M for magenta. And we'll see that we get a purple-pink line there. But if we want to change it to dashed lines, if we looked at the documentation, we can give it this 2 dashes as a string, and we'll make it a dashed line. And so if I do M dash dash and I run it, then you see that we get a dashed line. Okay? So the next thing is, any questions on that? Okay. And so the last thing is we're going to make it, or probably the last thing we have time for, is we're going to draw the sine wave with a 5-point size. And so what we actually want to do is, let's see, oops. If we go back to the hints, we saw that we can give it a, I didn't go to the right spot. There we go. Okay. So we saw that we can give it, like, if we take a look at this example down here with the dot plot, we have a color, we have a line style. So this is another way we could have done it. We could have said color is equal to magenta, comma, line style is equal to dashed. But then we also have something called marker is equal to this, and then marker size is equal to 12. And so if I come back to, maybe we'll do the sine wave here, right? So if I come up here to where we actually plot it, if I say marker is equal to an O in quotations, or as a string, and if you run it, we see that we get something like that, which looks really ugly, but if we zoom in, we see that we can actually see like the individual points, and we see that we have like a circle there now, right? And so, and if I change this to a star, we see that we get like stars now. It's really hard to see, but we have stars there now instead of circles. And if we take a look at the example, we saw that there we can give it a marker size. So if we go back to our code and we say, if we give it another argument, we say marker size is equal to 10. We see that we get, and let me change it back to the circles. We see that we get like bigger circles than before, because I think by default it's size of 1. And so like if we just change that back to 1, we'll get like a thinner kind of graph there. You can see the individual circles now. But if you want a point size of 5, then there we go. We have points of size 5. Okay? And so don't really have time for the last one. Does anybody have questions so far? Any last remaining questions? So if you really want something to do this weekend, you could do this last thing where you take a look at the plt.access statement and you pretty much replace the xlim and ylim with that. Let me know if you have any questions. I will be in the tutoring center for the next hour if you have any questions since John is gone. Have an awesome weekend. I'll see you guys next week.